Hello and welcome to EVPN config snippets. This is part 3 in this video series where we discuss and configure various Ethernet VPN designs. Here's the agenda for this video. We are going to continue with the centralized gateway design from video 2, and I'm going to deploy a couple of VRFs to that. Then I'm going to leak between them, so we'll discuss that and I will configure the VRF leaking and we will test it out. A quick recap of our setup for centralized gateway. Then I've got a couple of broadcast domains. I've got VLAN 10, I've got VLAN 20. Those VLANs are mapped to VNIs on this vtemp here, which is an HP Aruba 6300. I've called that CX1. We've got CX2 over here, which is also a 6300. The broadcast domain is extended down to this router, again a 6300, which will do the layer 3. The router down here is the layer 3 gateway for these networks. The upshot of which is that if I want to ping from server 1 to server 2, then that traffic will travel not just on CX1. It won't go like this. What it will actually do is the traffic will actually come from server 1 to the default gateway, which sits across the VXLAN tunnel here down to router 1. Router 1 will do the routing off of that subnet onto the destination subnet from 10.99.10/24 to 10.99.20/24. That routing will happen on router 1 and it will send the traffic back to CX1, which will forward it out to server 2. So that's our centralized gateway. And new for this video, what I'm going to do is I'm going to deploy a couple of VRFs. I'm going to deploy a VRF Blue and attach the layer 3 interface for VLAN 10 to VRF Blue, and I'm going to attach the layer 3 interface for VLAN 20 to a different VRF. Can you guess the name? Of course, it is a VRF Green. Now, you'll be forgiven for thinking, looking at the way that I've illustrated this, that the configuration of the VRFs would be on CX1 here or maybe on CX2, but actually we don't have to touch the config of these two devices at all, and the reason for that is that they are layer 2 vtemps. Now, a VRF does not get attached to a VLAN directly. What we have is we've got the layer 3 interfaces for those VLANs, also known as a SVI, and we attach the VRF to those. And that layer 3 interface, that sits on our router 1. So our configuration of the VRFs is on router 1. That's what we're going to be focused on. And now you may think that that's a bit of a problem looking at the network like this, because, it kind of looks like blue can speak to green here. Where's our segmentation? Well, our devices here, what they do is they have traffic segmentation in the data plane. We've got the VLAN for segmentation when it's the 82.1q switch network. And we also have that map to the VXLAN VNI to keep the traffic separate and segmented as it traverses this layer 3 core. Let me just go back so you can see that. So we've got the VLAN 10 mapped to 10,010. The traffic from here will be kept separate as it traverses the network up to the router. So we will have traffic segmentation in our network. Here's another way of illustrating this network that I think really brings this home. Because from the point of view of server 1 and server 2, they don't know about the EVPN VXLAN network that sits between them and router 1, because when they send an ARP, that broadcast is received by router 1. The vtemps are essentially transparent to them. Router 1 is the layer 3 gateway for their subnets, and we are putting this interface, essentially the layer 3 interface for VLAN 10, into VRF Blue, and for VLAN 20, the layer 3 interface is going into VRF Green. Let's have a look at the sample configuration that I am going to add to router 1. Here it is. Now, there's quite a bit there, so let's step through that step by step. First of all, what I'm going to do is create a VRF globally for blue and green. Then I'm going to add the route distinguisher. I've manually configured this. I haven't used auto for this. For blue, I've just gone with the AS, which was 65001:10. And this is the value that's attached to prefixes within this VRF, because you can, with VRFs, have overlapping addressing, and you need some way to distinguish between the different routes in different VRFs. The way that we do that is with, of course, a route distinguisher. Then I've configured an IPv4 unicast address family. Now, the point here is that remember that the router 1, the centralized gateway, is not an EVPN device. It's just a layer 3 device. And so this configuration is different from configuring VRFs for EVPN VXLAN. This is just an IPv4 unicast VRF that I'm configuring here. And under that address family, I've configured the route targets, which I've manually configured. I've just used the same values as I did for the route distinguisher. So we've got the export and the import. Then I've done the same for VRF green. Notice that the route distinguisher is different, of course. So 65001:20, and the route targets I've gone with the same, 65001:20. Now that configures VRF blue and VRF green for us, and then we add that to the layer 3 VLAN interfaces. As you can see here, interface VLAN 10, I've attached blue to that. And just to reiterate that point, we are not attaching the VRFs. They don't go directly on the VLANs, they go on the layer 3 interfaces. It's layer 3 interfaces that are attached to VRFs. And don't forget that when you do that attach, if you've already got the interface configuration on the device, that will wipe the IP addressing from it. So remember to configure those IP addresses back in. That's an easy one to miss. As you can see, I've done the attach here for blue against interface VLAN 10, and then I've done the attach for green against interface VLAN 20 and put those IP addresses on there. And with that configuration deployed, we will have server 1 sat in VRF blue, and we'll have server 2 sat in VRF green. And by default, that means that we're not going to be able to perform our lovely ping test between server 1 and server 2. They will not be able to communicate now because we have this VRF level segmentation. And this is quite a common design that we see within enterprise campus networks, where customers want to be able to control their traffic flows within their network, segment it into VRFs, and actually push the traffic up to this centralized gateway point. So this would be, rather than just being a layer 3 router, this may well be a firewall as well, so they can apply their security enforcement at a centralized point. But it's also quite common to want to have some form of inter-VRF connectivity. So for example, to be able to allow server 1 to communicate with server 2 in our example. And the way that we do this is a process of VRF leaking. And the way I'm going to configure this is, there's various ways to do this, but this is the one that I know best, which is on my router 1, I'm going to configure BGP, and I'm going to inject the layer 3 prefixes from the VRFs into BGP, and then use the route targets, so importing the route targets between the VRFs to create this VRF leaking. As you can see, there's a number of additional steps there. Let's have a look at some sample config. Okay, and here's the config. Now, this is what it will look like on the device, but we'll step through more in a kind of chronological order that I would add this in. So I think it makes a bit more sense. So step 1 would be on this device. Remember, it was just a layer 3 device, not EVPN. I'm going to configure BGP for the first time on this device. That's step 1. Step 2 is to create the IPv4 unicast BGP address family under the VRF. As you can see here, IPv4 unicast under VRF blue, and then inject that local layer 3 interface into BGP. That's what I'm doing here. 1099.10/24 will sit in the routing table assigned to VRF blue at this point. And essentially doing the same for VRF green, create the VRF under BGP, add in the address family IPv4 unicast, and inject the network 10.99.20.0/24 4. That is step 5. And then up here, now this is the global VRF. So, and I know people that are new to this stuff can be quite confusing. This is a router BGP command here. So for VRF blue and green under BGP, you're creating those address families assigned to those VRFs. Up with the global VRF configuration, what we do, we have the route targets there, and we are going to essentially, this is where we do the leaking. So you can see here what I've done is I've added an additional import statement for the route target, which is coming from green. So this export here, this 65001:20, I've imported that into blue. As you can see, step 6, import from VRF green :20 into VRF blue, that's here. And finally, step 7 is to import from VRF blue into VRF green. Stepping through then VRF green globally, under this address family here, the V4 unicast address family, I have taken the export statement value from blue 65001:10 and I've imported that into green. Essentially what that means is that the network that's in the VRF blue IPv4 unicast address family, all being good, that would be 1099.10/24, that will appear in the VRF green address family because we have exported it here with this route target and we have imported it here with this route target import statement, and vice versa. Let's get configuring that then, and I'll do some show commands which will really bring it home what's happening with these prefixes and the leaking, and we'll do our lovely ping test. Hopefully you know the drill. We've got the configuration windows at the top here. I'm on server 1 here, so this is server 1, and I'm on router 1 here, so this is router 1. I'll keep the diagram up. We'll do the config at the top here, and I'll jump between different windows as and when. To start with then, let's prove the setup. We're not even going to look at the vtemps because the vtemps at this point is the same as video 2. What I'm going to do, focus on server 1 and the fact that at the moment it can ping from server 1 to server 2. So pinging 1099.20.16, that works. That traffic is flowing across the VXLAN down to router 1, back across the VXLAN and down to router 2. Okay, so when we implement the VRFs, that ping will not work. Let's have a look at router 1's config. This is all basic stuff. There's not much on there. It's just those 2 layer 3 VLAN interfaces, VLAN 10 and VLAN 20. Let's go in stages then. I will start by implementing VRF blue and VRF green, and at that point, once I've assigned the VLANs to the VRFs, then server 1 will not be able to ping server 2, and then we'll do the VRF leaking. Sound good? Right, no objections heard, so I will continue. Right, so VRF blue over on router 1, remember that's global. We'll give it a route distinguisher. I'm going to do all of this from memory. Address family IPv4 unicast. Yeah, there we go. And route target, I'm going to, can I do both? Yeah, I can do a both, right? We'll put in a both, C5000110. Notice that I'm doing this all manually because this is not an EVPN device. This is just a standard IPv4 unicast VRF. Done. Okay, and then let's do VRF green. I'll do it in stages. So VRF green, and I'll do route distinguisher 65001:20, address family IPv4 unicast, route targets both, and I'm going to go with 20. Let's have a look at that. There we are. Okay, so blue and green ready to go, and I'll show you. I'm trying to always do this as though I'm talking to someone that doesn't have much experience with this kind of thing, or is just looking for a refresh. So watch this, right? What I'll do is we attach the VRF to the VLAN 10, and it's going to be VRF attach, and then the VRF name. So the VRF is blue. Now, if we do a show run interface VRF 10, you see what it's done is it's taken off the IP address, because this IP address was essentially the IP address that was valid when it was the layer 3 interface in the default VRF, which with CX, everything is essentially in a VRF of some kind. These IP addresses, if you're not explicitly assigned to a VRF, you're in the VRF default. So we've attached that layer 3 interface to the VRF, and the operating system removes the IP address. It's just a case of adding it back in, so we'll copy and paste that in. There we go. Run that again. And you can see we've now got, it is this interface here, essentially, on router 1, that interface there. Do you like my big cursor? Hopefully it's a bit easier to follow. That's why I've got this jumbo cursor, okay, that I've set up in system preferences of macOS. Okay, next one then, VLAN 20, and we're going to do a VRF attach for green. And the IP address is 1099.20.1/24. Okay. All right, show run. There's our VRFs. And there's our VLAN interfaces. Okay. Now at this point, I'll run the ping. So this ping is server 1, which is in 1099.10. Its IP address is .16. We're going to try to ping server 2. Can we ping? There we go. No, destination. And this is interesting because you actually get a message back from the gateway to say the destination net is unreachable. So you can see that the response is coming from router 1 here. It's responding saying it can't get to that destination subnet. Right, that's because we now have this segmentation, and you can see that on router 1. If you do a show IP route, this is default, okay? So everything on the box is in the VRF default, okay? That's the same. We've moved those connected interfaces, the L3 interfaces, out of VRF default, and we've put them into the respective VRFs. Right, okay, so this is blue. You can see there, that's the connected interface, the subnet, and the actual locally configured IP address. So that's this one here, is the 1099.10. And so these are in different routing and forwarding tables. That's what a VRF is, different routing and forwarding tables. So from the point of view of the device looking in the forwarding table for VRF Blue, we can't see 1099.20.0/24 anymore, because that's in a different table. We've segmented the forwarding of this device. So if we look at green, you can see there's 1099.20.0/24, and if we do a show IP route to 10. From green, let's have a look at blue. Then what would you see? I think we put in VRF, so this would be from the point of view of green. We have no route to that. We've carved the routing table. We've taken it out of the default and put it into the respective VRFs. So if we were going to do a route to green, essentially this ping here that we've asked it to do, the packet will arrive 20.16, and we are in VRF Blue. We don't have a route to it, okay? So that's why we've got this segmentation. And you can see here that actually the part that I mentioned before, that the configuration is here on the router, on the gateway. This is the L3 gateway, but the traffic segmentation in the data plane is maintained because you've got this, well, that's a physical port that's assigned to a VLAN there. So you have the broadcast domain here, and then the traffic is segmented across the VXLAN network using the VNI. So in the data plane, we actually have that VNI, which the identifier that keeps the traffic separate. So the traffic from server 1 to server 2 is kept separate on this box, even though there's no VRF on there. It is segmented, and the CX1, the VTemp, will just ship the frames that are hitting the this interface here and put it across the VXLAN network to get to the layer 3 gateway. Okay, so our ping doesn't work at this stage. Okay, at this stage, we can't ping between the VRFs, and I said that we would show a configuration for VRF leaking where we can. Let's do that now. And I did mention there that there are multiple ways to do this on a CX box, but I'm going to go for the one that I've always done, which is essentially you use BGP to import the network into a VRF specific table, and then you export that and you use the route targets to import between the different VRFs. So showing you that then, route of BGP, and here, this is VRF specific. So I'm going to enter VRF blue. I'm going to create an address family, IPv4 unicast, and there's various ways to do this. You could do redistributed into this. I like to use a specific network statement. So that will be the blue network that I'm putting into this VRF blue BGP table, like so. And I'll come out of there. And now I'm going to create a BGP VRF green table for address family, essentially, for VRF green. And I will inject the prefix for green into there. Okay. So let's have a look at those. So show BGP. What's the command for this? So we will go VRF blue, and it will be the IP unicast. Okay, that's the until I'm doing this for the first time in a while. This is router 1 then. That's the command to show the VRF blue BGP IP unicast table. So we enter that command. What can you see? You can see this subnet which we've injected on router 1 there. We're under this VRF blue BGP table. There's the route distinguisher that I added on there. I think if we do the let's have a look. Yeah, so if we go 10.99.10.0/24, you can see the full entry there, okay, for that network. And there's the route target, okay, 65001:10. Good stuff. Let's have a look at the same for VRF green IP unicast 10.99.20.0/24, and you can see there that is the prefix within the green IPv4 unicast VRF green table, and you can see that route target that I assigned to the VRF green. Now if we look at the IP routing table for VRF blue, you can see, so it's just the local. This is the same as before because we've got an actual connected interface within that subnet. So we're not actually learning it via a BGP update or anything. We have injected it into BGP as you just saw, but VRF blue, it's got a connected interface in 10.99.10/24. And so that's what's in the table. We still can't see the neighboring interface. Just to make that explicit, okay, we can't see. And also, can we ping? Of course we can't ping yet. Okay, so we're getting the same outcome. And now to do this is the actual leaking part. Okay, so I'll show you the config as is. Right, there's blue, and what we're doing is in VRF blue we have the 10.99.10.0/24 prefix. We want that to go into green, and we want green's 10.99.20.0/24 prefix to go into blue. And the way that we do that, to be leaked into blue, I should say, right? So the way that we want to do that then is that we reverse these. We take the export statement, so the route target from blue to get blue's 10.99.10/24 into the green table. We import this route target that is exported out of blue of 6500 1:10, and for the reverse with green, to take green's prefix and see that within blue, we take this root target that it is exporting and we import those into blue. So that's our root leaking. Okay. That means with blue, what we do is I'll go into the address family IPv4 unicast and I'll do a root target import 65001 : and I'm importing green there. So 20. Okay, and if we look at the routing table for blue, you can see that we do have, actually, there we go. So you can see that we have the destination subnet coming from green, and you can actually see the egress, the fact that this subnet is within VRF green. So blue has to send, we're sat in the VRF blue. This is blue's point of view of the world. And to get to this prefix, we have to go out towards VRF green, and it's actually given us the interface. So it'll be interface VLAN 20. So that's the VLAN 20, that's the one that's attached to green. Interesting stuff. And and you can also see there that this route has got an origin of BGP. Where is the code for that? So this will be the origin code up here, BGP, and it's internal BGP. And before we finish the config off by configuring VRF green and the import statement from blue, I want to just prove that server 1 cannot get to server 2. Okay, so server 1 pinging server 2 is still failing. So blue knows, so that on router 1 we know how to go from blue out to green, but the ping of course is an echo request and an echo response. So we need to have end-to-end bidirectional traffic for this ping to work. And at this stage we can get to server 2, but the traffic coming from server 1 knows how to get to the destination VRF. We've leaked that, but we don't have the return route. I will leave that running there. Let's go on to VRF green, and we'll go the address family IPv4 unicast, and we will do a root target import. And for this we want, what is it, 65001 : 10. So this is blue's root target. If I hit that up immediately, you can see it starts working. We've got end to end. If we look on green, so show IP route, VRF green, you'll see there the destination, and again it is BGP internal. We can see the interface and the fact that to get to this address we have to go out. So this will be the return traffic from my ping from server 1 to server 2, coming back from server 2 to server 1. Okay, if you bear with me there, this is the entry that we'll use. We need both entries to get that end-to-end bidirectional traffic. Put this across here. You can see the ping flowing there. And I always like to do stuff like this where we'll go back in, config router, what should we do? VRF blue. And I will go to the address family, IPv4 unicast, and I will show VRF blue. Can we get the, no, we can't get that, come on. Okay, what I'll do is I will, root target, I will take out the import statement for green, which was 20. So as soon as I take that out, we start to fail. You can see this over here. We don't have that in our forwarding table anymore. And then if I add it back in, it should, and it does, start working straight away. And that is a VRF configuration, creating this segmentation, plus then we've done some leaking. All right, well, actually, to show you the next part, let's give you the whole configuration. So the full config here, you can see blue, and we've got that additional import statement coming from green. That's a mirror of this one here, the :20. You can see 20 in there. VRF green, we've got the import of blue. There's no additional config until we get to the VLAN 10 in VRF blue. VRF green is attached to VLAN 20, and then the way that I've done the leaking is create BGP, create the VRF cable for IPv4 unicast under that VRF, injected the local layer 3 interface subnet there, and done the same for green, which means that then with the route targets, because we've got them in the BGP table, we can use the route targets to do the imports and the exports. And just to finish up here, because I do see with enterprise campus networks where we are implementing multiple VRFs, and it seems to be a very direct line between let's implement VRFs and very soon afterwards I hear and we want leaking. It's a very common approach to implementing VRFs where they're not completely separate. In the past, I would say, when I was looking at MPLS L3 VPNs, and when I worked for a service provider, the different VRFs would be different customers. So we would have, say, I won't say the actual names, even though it's a while back. You would have something like a media company or a retail unit, and so the media company and the retail units, they would never speak to each other, so you would have those as specific VRFs across the network, and there would be no leaking between them. But with enterprise campus networks, it seems like we've got multiple VRFs deployed, and then and as I say, this is opinion, very often they are leaked, sometimes over leaked, I think, because what's the point of implementing a VRF or a VPN if anything can speak to anything anyway? Maybe there would be an argument for that to say, okay, but what we're doing is we are applying our security policy on the firewall at this point. But, if you're implementing VRFs and you are leaking them, you can't do your overlapping addresses anymore in most cases, right? Because how would they get to these different prefixes unless you're doing something funky with longest batch of the prefix, which is possible, but essentially, if you're implementing the VRFs, there really should be a reason for them. Don't just implement them and leak everything. Okay, if you're doing, like I said, if you're doing the centralized enforcement, you might want to make sure that everything is shipped up. But, by default, don't just think, right, I need all my VRFs and everything needs to be leaked, because essentially, if everything's just can see everything, then there's not that much point implementing the VRFs in the first place and having all the additional config overhead and the complexity of it. Don't overshare. Don't just don't implement 10 VRFs and then just say any to any with the leaking. And just to reiterate, that is just my opinion around this. Please do configure your VRFs and leak as much as you like, however you should so choose. I'm sure there's good use cases for this. Okay, so I think that's a wrap for this video. We implemented a couple of VRFs on our centralized gateway approach and creating the segmentation between the VRFs so our servers couldn't ping. And then I did VRF leaking using the old multi-protocol BGP import-export route target method. And that just leaves me to say, my name is Joe Neville. Thank you for watching and goodbye.